Hello friends, today I am going to talk about semiconductor lasers. So let us first know what is a semiconductor laser. A semiconductor laser is a device that causes laser oscillation by flowing an electric current to semiconductor. The mechanism of light emission is the same as light emitting diode. Light is generated by flowing the forward current to a PN junction. In forward bias operation, the p-type layer is connected with the positive terminal and the n-type layer is connected with the negative terminal. Electrons enter from the n-type layer and holes from the p-type layer. When the two meet at the junction, an electron drops into a hole and light is emitted at the time. The material which often used in semiconductor laser is gallium arsenide. Therefore, semiconductor laser is sometimes known as gallium arsenide laser. So next topic is basic structure of semiconductor laser. Here we can see this is the basic structure of a semiconductor laser. The active layer sandwiched between the p and n type clad layers is formed on an n type substrate and voltage is applied across p-n junction from the electrodes. Both edges of the active layer has mirror-like surface. When forward voltage is applied, electrons combine with the hole at the p-n junction and emit the light. The light is not a laser yet. It is confined with the active layer because the refractive index of the clad layers are lower than that of the active layer. In addition, both ends of the active layer act as a reflecting mirror where the light reciprocates in the active layer. Then the light is amplified by the stimulated emission process and laser oscillation is generated. So the next topic is type of semiconductor lasers. First is the Fabry-Perot semiconductor laser. This laser has the simplest structure and is used for many applications including optical pickups for CDs, DVDs, laser printers, and excitation of fiber lasers. It is characterized by the use of cleavage plane of a laser crystal for reflection of light emitted in the active layer. As we can see in the figure, a cleavage plane of a crystal is extremely smooth and can be used as a reflecting mirror. Since Fabry-Perot has no mechanism to select a specific oscillation wavelength, the multiple laser oscillation occurs within the gain bandwidth as shown in the figure. The oscillation at multiple wavelengths causes pulse broadening in an optical fiber transmission and therefore it cannot be applied for long distance communications. So next type is the DFB semiconductor lasers. The DFB laser or distributed feedback laser has a grating below or above the active layer and oscillates at the single wavelength defined by the break wavelength of the grating. It exhibits superior performance, including a narrow spectrum, width, and low noise, and hence is used as an optical signal source in a long-haul optical communication. Next type is the FBG wavelength stabilized semiconductor laser. Though DFB laser has an excellent performance like a single wavelength oscillation, it is expensive for manufacturing difficulty. More economical laser to oscillate a single wavelength is a laser diode stabilizing the wavelength by using FBG. In this case, the laser cavity is composed of the HR-coated and face of the active layer and the low reflectance FBG. The other end face of the active layer and the incident end of fiber have air coating to prevent reflected light. In addition, the incidence end of the fiber is processed to a lens configuration to collect the light. Since the FPG formed in the fiber core only reflects a specific wavelength, a single wavelength oscillation occurs. So now let us know some characteristics and applications of semiconductor lasers. Some typical aspects of semiconductor lasers are electrical pumping with a moderate voltages and high efficiency is possible, particularly for high power diode lasers, and allows their use. Example as pump sources for highly efficient solid-state lasers. A wide range of wavelengths are accessible with different devices covering much of the visible near-infrared and mid-infrared spectral region. Some devices also allow for wavelength tuning. Small laser diodes allow fast switching and modulation of the optical power, allowing the use, example, in transmitter of fiber optic links. Such characteristics have made semiconductor lasers the technologically most important type of lasers. Their applications are extremely widespread, including areas as diverse as optical data transmission, optical data storage, metrology, spectroscopy, material processing, pumping solid-state lasers, and various kinds of medical treatments. One of the most important applications is pulse output. Most semiconductor lasers generate a continuous output. Due to their very limited energy storage capability, they are not very suitable for pulse generation with Q switching, but quasi-continuous wave operation often allows for significantly enhanced powers. Also, semiconductor lasers can be used for generation of ultra-short pulses with mode locking or gain switching. The average output power in short pulses are usually limited to at most a few milliwatts, except for optically pumped surface-emitting external cavity semiconductor lasers, which can generate multi-watt average output power in picosecond pulses with multi-gigahertz repetition rates. Next important application is modulation and stabilization. A particular advantage of the short upper state lifetime is the capability of semiconductor lasers to be modulated with very high frequencies, which can be tens of gigahertz. This is exploited mainly in optical data transmission, but also in spectroscopy for stabilization of lasers to reference cavities, etc. So let's move on. So now let's know some of the advantages of the semiconductor laser. Smaller sizes and appearances make them good choices for many applications. Also, from some point of view, the semiconductor lasers are economical. Semiconductor lasers are construction. Semiconductor lasers constructions is very simple. No need of mirror is in semiconductor lasers. Semiconductor lasers have high efficiency. The low power consumption is also its great advantage. Now let us know some of its disadvantages. So number one, due to relatively low power production, these lasers are not suited to many typical laser applications. Next, semiconductor laser is greatly dependent on temperature. The temperature affects greatly the output of the laser. The lasing medium of semiconductor laser is too short and rectangular, so the output beam profile has an unusual shape. And lastly, the beam divergence is much greater from 125 to 400 milliradians as compared to all other lasers. So this was all guys. Thank you for watching.